And before we go over any examples, we need to go over one more theorem. It's the similar circles theorem. Similar circles theorem is pretty basic. The similar circles theorem states all circles are similar. What that means is there's always a scale factor. The scale factor would be the length of one radius to another, or it could also be the length of one diameter to another. That would be the scale factor for similar circles. Now going over some examples, we want to try to figure out if the arc that's given is a major arc, minor arc, or semicircle, and then find the measure of the arc. So make sure that you're doing both of these. Okay, here's what's given in the diagram. AC is perpendicular to BE, so I can make a little right angle here. What that means is this angle is 90 degrees, this angle is 90 degrees. This angle, which is a central angle, DEC is 40 degrees. We can actually find the measure of angle AED. Because if I add up 90, that's 180, plus 40, that's 220. And then if we subtract 220 from 360 degrees, because a full circle is 360 degrees, so 360 minus, as I mentioned, 90 plus 90, 180, plus 40, 220. So that's 140 degrees. That's a measure of this central angle right here, 140 degrees. And then we can use those central angles to find the measure of arcs. Minor arc AB would be the same as the measure of its central angle, 90 degrees. Minor arc BC would be the same as its central angle, also 90 degrees. Minor arc DC would be the measure of its central angle, 40 degrees. And then arc AD, which is also a minor arc, would be 140 degrees. And now we could use all of those measures to help us first find the measure of arc AB. So arc AB, first of all, is a minor arc. And then the measure of arc AB, if I write it correctly like this, would be what I have labeled in my diagram, 90 degrees. Arc ABC, that's from A to B to C. That's half a circle, so that's a semicircle. And then the measure of arc ABC, 90 plus 90, we're using the arc addition postulate, 180 degrees, or any semicircle would be 180 degrees. The measure of arc AB to D. Okay. First of all, that's more than 180 degrees because it's more than the semicircle, so it's a major arc. And the measure of arc ABD is 90 plus 90 plus 40, or 220 degrees. BC is a minor arc, and then the measure of arc BC we have labeled as 90 degrees. Arc BAC, that's this arc right here that I'm tracing out. Let me use a different color, or I'm just going to use a pencil because I have a lot going on there, but this arc right here, B to A to C, 90 plus 140 plus 40, or 180 plus 90, so that would be 270 degrees. That's definitely a major arc. Measure of arc DAB, D to A to B. That's a major arc. It's more than 180, but it's 140 plus 90, so 230 degrees for the measure of arc DAB. Arc AD, we had found earlier. First of all, it's a minor arc. It's less than 180 degrees, and the measure of arc AD, if you can see I have it there in orange, is 140 degrees. Lastly, arc CD is the red arc. Sorry, there's a lot going on, and you might not be able to see it that well now, but that's definitely a minor arc. And then the measure of arc CD is 40 degrees.